Hi, good afternoon. I apologize for the abrupt change in languages, but trust me, you don't want to hear me speak about iron in Hebrew, so bear with me. Today I'm going to present some pieces of my PhD work, mostly the methodology, so you can understand why we look at the types of artifacts we look at and how we go about analyzing them. To start, there are 6 sites in the southern Levant with iron production remains that date to the Iron Age 2A. That's the late 10th and the early 9th centuries BCE. These workshops are the earliest evidence for local production of iron in the region and some of the earliest examples of iron production in the world. In order to gain new insights into the technology and practice of iron production, in its earliest phase, the research I'm involved in uses methods from a variety of fields that are commonly employed in the subfield of archaeometallurgy. Archaeometallurgy, as its name implies, explores technological, historical, and social aspects of ancient metals, their production and use. And the research focused on the Bronze and Iron Ages deals with 6 different metals in this period, precious metals being silver and gold, and non-precious metals being copper, tin, lead, and iron. In addition, there are multiple different combinations of these metals, which are referred to as alloys. An example of this alloy being bronze, which is the mixture of copper and tin. So we're talking today about the history of technologies, and when speaking about metallurgy, we have to address the questions and the introduction and advancements in pyrotechnologies. So how humans were able to use fire and heat to affect and change the properties of materials from nature on a structural and chemical level in order to create new materials and new objects. And it was often that revolutions in pyrotechnology allowed successful innovations in metal production, and this applies to many other human-manipulated materials such as ceramics and glass. And because the approaches range from macro to micro levels of investigation, archaeometallurgy is very interdisciplinary. It includes specialists from fields in archaeology, anthropology, material science, chemistry, geology, and often includes modern craftspeople. That's people who are still producing metals in traditional ways and observing how it is that they do that. So, to establish a chronology for the introduction of iron technologies and to understand why this research is important, we go back to the first appearance of iron objects in the region. In the early 1900s, the earliest examples of iron came out of the ground. The iron beads from the early Bronze Age tomb at Gerza, south of Cairo, and the famous iron dagger wrapped inside the sarcophagus of King Tutankhamun in the Valley of the Kings dates to the late Bronze Age. And these are 2 examples of iron used prior to its major exploitation in the ancient Near East. And despite that archaeologists have known about these objects for nearly 100 years, it has taken until the last 5 years for these scientific analytical methods to provide conclusive data about how these early iron objects were produced. So you can get a picture of how these techniques are not quite caught up with our research questions, and we're still working to be able to answer these questions conclusively. So these recent studies finally put to rest a debate as to how such early examples of iron occurred in the archaeological record. And it was conclusively discovered that meteoritic iron, which originates from meteors that have fallen from outer space onto the Earth's surface, that this rock is composed of such pure iron that it could be collected by an ancient craftsperson and used just as it is. So only hammering was required to turn this rock into an object. So this is the stage 1 in humanity's ability to work and produce iron artifacts. And in this period, objects are extremely rare, making it evident that the availability of this material, meteoritic iron, and the knowledge of how to work meteoritic iron was very rare as well. In our stage 2, our current understanding of the second stage of ironworking involves the introduction of a completely new technology. One more similar to the methods used for copper production called smelting. The metal craftspeople were utilizing a new process for iron called bloomery smelting. And while we do find objects in the late 12th and 11th centuries that are made from this technique, there is a total lack of production material in early phases of the Iron Age, which is somewhat problematic for our understanding of the arrival of this new technology. And here you can see the results of a recent study that counted the number of bronze to iron objects throughout the Iron Age. And you can really see this mark when people start producing, when we do have the evidence of production, quite nicely correlated with this extreme rise in, extreme, we don't have too many objects, but a markedly extreme rise in the number of objects that are found in settlement sites in the period. So based on archaeological evidence, our current understanding of bloomery smelting is as follows. It begins with ore, or a rock that contains iron, that is not pure like meteoritic iron, so processes needed to be done to remove that iron from the rock. It's heated in a furnace or a pit to a temperature somewhere around 1,000 to 1,200 degrees Celsius, at which this point the rock begins to melt, and the separation process can occur where the iron metal is extracted from the other elements and minerals present in the rock. This is essentially the production process of copper, which has been utilized for the past 6,000 years. However, technologically speaking, copper is far easier to produce because the melting point for iron is about 500 degrees higher than that of copper. So it's assumed that ancient peoples were not able to create a heating environment high enough to completely separate iron from all the other material in the rock, so the smelting process needed to be adapted. The initial process produced something like a bloom that you see here, which is sort of this spongy mass of the iron material and all the other material that's left from the host rock. This then needed to be purified, so the bloom was reheated and was hammered using a process called smithing, which forces out all of these extra materials that are no longer wanted in the object. Each step in this process produces a distinct byproduct, this byproduct being called slag, which are discarded after production, meaning that through these byproducts, or essentially the trash of each of these actions, we can attempt to reconstruct which aspects of this process was taking place at each archaeological site. And it also allows us to even spatially define activities within a workshop. So in addition to the final object, which we have become more and more common in the archaeological record, there are three types of artifacts that are found in almost all early iron workshops from this period. We do have iron slags from multiple different processes. We do have hammer scales, which are small flakes of slag that come off during the smithing or hammering process. And these are a fantastic record holder to exactly where smithing or hammering activities were happening within workshops. And I found this nice picture yesterday of someone in Denmark practicing traditional smelting. You can really see these flakes that are left behind on his anvil. We do find these in the archaeological record. We also find square profile tuyères. Now, tuyères are clay nozzles that direct air into the furnace to supply oxygen and help to regulate temperatures in the heating environment. Square tuyères first appear for the first time in the Iron Age 2A, so they arrive at the same time that this iron technology is arriving as well. The ones used in copper smelting and alloying for bronzes prior to that are all circular in profile. So this is a nice marked technological change that we have. It's arrival of a new tool that's being used that can be associated with the technology. In the work of Alexander Velhoitzen, which is one of the first researchers to work on actual workshop context in the archaeological record, showed that these objects, the tuyères, have a high level of standardization in their form and in their size, and ultimately concluded that this tool, and probably the technology for iron, must have been introduced sometime earlier than the 10th century, but only came to the southern Levant in this time, which makes sense since we have objects earlier. Unfortunately, there are multiple stages of the process we cannot account for in the archaeological record. As of now, little is known about the source of ore used to make iron objects during the period. This also goes for the type of structures used for melting and heating processes. Almost no furnaces or heating installations have been uncovered. While they may have been something simple as a pit, they're rarely found in situ during excavations. And finally, the preservation conditions of iron objects often obscures our ability to define what they are exactly. The picture here is a nice knife that has been found from Megiddo, but often there are little crumbly pieces of iron left over. So it's very difficult to define these two stages between the bar and the tool. A bar being something that would be traded. It's a semi-finished product, like a copper ingot. A lot of people are familiar with the oxide ingots from Cyprus. So we have a very difficult time to reconstruct maybe this trade environment or how people are using iron as a trade object because it's difficult to define between these bars and these tools. I'll skim through this briefly, but we do have several artistic renderings of metal production that do help us fill in these gaps. They're rare, and none of them come from our immediate region, but we can thank the Egyptians and the Greek cultures who are very diligent in documenting their daily life. The image of copper smelting in the bottom corner down here is from a couple hundred years prior to iron production, but it's the most relevant for us today. And we can get a basic idea and understanding of what was required for the metal craft, what tools, what sort of space, and then what the craft looked like from the ancient perspective. To fill in a few more of these holes, we can look at examples of ethnographic research. This is obviously a modern-day workshop, but it still has elements such as a heating environment, this tuyere system that supplies air. This is made from leather. We think from 3,000 years ago, these bellows systems that were supplying air into the furnace were also made of leather. The anvil that needed to be used to extract the slag from the iron, and then various other tools that were involved in a workshop. So looking at examples like this, also like this one from Northern Africa, we can sort of try to fill in these pieces that we don't find. What are these crumbly pieces of iron we find here? Where have these tuyères should have gone into the process to fill in a few of these gaps? So in recent excavations in the lower city of Tel Asafi, ancient Philistine Gat, a large metal workshop for the production of bronze and iron was exposed. The workshop is a long rectangular-shaped hall stretching more than 80 square meters. And to the workshop's immediate east, a large cultic structure was found with a two-horned stone altar and vessels such as votives and pedal cult stands. The area was excavated using microarchaeological techniques geared towards the retrieval of relevant data from a metallurgical context. And this is a fancy way of saying we sampled the heck out of every piece of dirt in the entire area and have run analytical tests on all of it. And through this testing, we can pick up several hot spots or concentrations that have been identified. And they're areas with a large amount of ash and metallurgical artifacts, surfaces where the sediments seem to have been high heated. And then we do have several taboons in the area, these circular structures. It's common in workshops in this period, these taboons, but they're the most frustrating objects we ever find. They seem to have no connection to the metallurgical process. They look like a nice round environment to smelt your iron. They have no iron in them. Maybe they were used to make charcoal. Maybe they were just roasting some lamb while they were making iron, but unfortunately, they are not our furnaces. Metallurgical artifacts from the area include tuyères, which I mentioned before, slag, which are these nice bumpy little orange and black rocks here, and fragments of crucibles that attest to copper alloying. As of the excavations this summer, we've collected about 45 kilograms of slag. This is a huge amount. It's the largest amount that's been found within Israel at a workshop. There's major variation in types of slag from Safi, meaning they appear to come from a wide range of activities. And as I said, different parts of the process produce different slags with different visual appearances. And the slag from the workshop appear to cover a wide range. So a central question of the study is how do we chemically or structurally define smelting versus smithing? So these two processes of hammering and of initial smelting, taking the rock and turning it into a bloom, both create slag. In order to define these, we have to look at the chemical and microstructural composition of these, and we ask ourselves, and many researchers have asked themselves, is it possible to determine from the slag material what processes are taking place in the workshop? This has been a central question for researchers because the answer to this question has profound implications for the networks of iron production, affecting trading of raw materials, access to the technology, and the autonomous abilities to produce one's own objects and own iron within a city environment. We can confirm that the entire process took place, or excuse me, can we confirm that the entire process took place within the walls of the ancient city, or are workshops in this period more specialized, performing the final steps of the process, which was the case in copper and bronze working for the entire Bronze and Iron Ages? So it's a difference of having to, say, go to Timna or Fenan to get your copper, have a large trade network that could then bring that copper to the city, and then people are finalizing their objects and creating the objects based on demand within the city. Is this the same situation for iron? And because we don't know our iron source, we don't know what type of rock they were smelting, we can't construct this larger network around it, which makes it very difficult to understand, does the does the production of copper rely on a network like this, or could anyone go out to their backyard, collect a few rocks, throw it in a furnace, and they were able to create their own weapons, their own agricultural tools? And this really changes the dynamic of how people accessed metals during this period. So, to determine which activities were taking place at each site, we went to the slag material, and here's examples of slag from Tel Megiddo and Tel Safi. You can see that they do look slightly different. The Megiddo slags are what we call plano-convex, these small things that look like they sat into a furnace, and our Safi slags are a little bit more crumbly and easily breakable. So we began by comparing these morphological and visual characteristics of the two collections, and immediately saw the greater variation of slag types at Safi than at Megiddo. The Megiddo slags look a lot like the 6 other sites that have been found in Israel. And I won't go into great detail about the processes, but it involves the preparation of samples, running a series of analytical tests, using a series of very expensive pieces of equipment that allow us to know very accurately what this material is composed of and how it was composed. So we have a giant saw in Jerusalem where I cut the slags in half, an optical microscope used for primary observations, scanning electron microscope, which is a very high-powered magnification, and then portable X-ray fluorescence, PXRF, which gives us the chemical composition of the slag. And these are techniques that are also used on iron objects. They're very commonly used in archaeometallurgy to look at any type of related materials. So here's our little slag sections. The results of all this cutting look something like this. On the left, you'll see Megiddo. On the right, you'll see Megiddo. On the left, you'll see Safi. And here are the images of their microstructures under high-powered magnification. From these images, we can tell how much iron was lost into the slag, which allows us to characterize how efficient the technology was. The iron is the white structures you see, and you can see in the Megiddo slags that the matrix is dominated by this white, whereas we have a less presence of the iron in the Safi slags. And we can tell what elements were in the slag, which help us reconstruct what type of rock it's composed of. We're still working on this aspect of it. And you can also tell exactly what conditions were in the furnace, the heat of the temperature, the height of the temperature, what sort of other elements were being added in, what sort of charcoal they were using, fuel sources, and so on. So hopefully allowing us in the end to make a nice, accurate reconstruction of the technology and then the world that surrounded that technology. Thank you.
תודה רבה.